Hi, student. In the last video, we learnt about some architectural block diagram. In that, we learnt about accumulator, B registers, and some other SFR, special function register. Along with that, now we'll discuss about the program status word. This is the main important concept what we're going to learn. Probably they're going to ask the question, explain the program status word in 8051 for 6 marks, or they're going to be asking that explain the flag register present in 8051. So that individually you need to explain the flag register. As we know that PSW, it is a bit addressable, as well it is an 8-bit register. We'll see that each bit how it is consists. So it has an 8-bit register. So we have the flags. One, we have the carry flag, auxiliary carry, and user flags. We are not using that F0 and F1, that is user required to design for the flags, and overflow flag as well as parity flag. And we have the register select, that is whatever we have the register bank 0, bank 1, bank 2, bank 3. So those register how we can select, so that is we can use by using RS0 and RS1. So we'll see some of the flags, how they are affected with respect to your instruction. A little bit brief some of the instruction here to affected to the flags. So these are the some of simple instruction like addition, subtraction, multiplication, division, and conversion from hexadecimal to a binary to decimal number, DAA what we are using, rotate instructions, complement, set, clear, and or so bitwise moving, and jump instruction. So some of the instructions are supported to the carry flag. So these are the instruction. We can see that what are the flags are maybe affected in these instructions. Probably we have the carry flag, overflow flag, and auxiliary flag. Probably they are affected or not affected. We'll see that. Okay, let me analyze with all the flag contents whichever we have that. These are the flags, how this set or reset with respect to some of the operations, and how we can identify those flags. We can see that. So first we can go with the carry flag. So carry flag obviously it is used for after performing the arithmetic and logic operation, there is a carry generated from the MSB bit, then carry flag will be 1, otherwise it will be 0. For example, I'll give this example 1 0 0 0. So let me take it as 1 1 0 0. I'm adding this number 0 0 1 0 1 0, and here the 1 is generated from the bit. This is the bit of your MSB bit. Okay, so this is let me take as the 8-bit register. So this is what we consider as an 8-bit register. So this is a value, let's say our addition value, it is done in the accumulator. So we'll have the values. We have an 8-bit data 0 1 2 3 4 5 6 7. Okay, let me erase one more here. So this is your D0, D1, D2, D3, D4, D5, D6, and D7 bit. Okay, whenever the bit MSB bit, this is your MSB bit is generated a carry, then the carry flag is set to 1. So as we know that this will be enabled when we done the arithmetic or logical operation performance. Otherwise carry flag will be 0. Clear? So in a bit, we first fourth bit we can call this is a nibble. This is we called as a nibble. This is a lower nibble and this is your higher nibble. So in the higher nibble, whatever the MSB bit, the D7 bit has generated the carry. Similarly, as we know that 1 byte is equal to 8 bits. Okay, 1 nibble is equal to 4 bit. And similarly 1 word is equal to 16 bit. So likewise we saying in the bit format. So same way, another one is auxiliary carry. Remember, I am taken as 8 bit. Let's say 1001 1000. Let's say 0110 1000. This is actually equivalent value is 8 plus 1 is 98H, and this is will be 4 plus 2 is 68H. If we added this element, the result will be there in the accumulator. Let me add this 0 0 0. 1 plus 1 is 0. The carry is generated here. It is added here. 1 plus 1 again it is 0. 1 plus 1 is 0. 1 plus 1 is 0. 1 plus 1 is 0. 1 again the carry out is generated. Okay. So here the carry is generated from which bit it is actually. So this is your third bit. Okay. Remember, so auxiliary carry, it will be affected after the performing of arithmetic or logical operation if the carry is generated from the D3 bit. See, this is your D3rd bit to the 4th bit. See, whenever the higher nibble bit, it is generated the carry to the 4th bit here. So then your auxiliary carry is set to 1. Otherwise, the auxiliary carry will be 0. I think you are clear with the carry flag and the auxiliary carry flag. Next, we'll have the register bank select. See, as we know that we have the registers, register bank, bank 0, bank 1, bank 2 and bank 3. 4 banks we having. Each bank we have the register R02, R7, and similarly same thing we have in each bank. Okay, see, default it is always taken as a bank 0. It is always taken as bank 0, that is used by R0 to R7 default. If I want to use the register of bank 1, how I choose, how I select, how I configure. So here we have the in the flag register RS0 and RS1 register bank select. So whenever it is 00, it is selected a bank 0. 01, it is selected as bank 1. 10, it is selected as bank 2, 1 1 it is selected as bank 3. Okay, each bank is having the 8-bit, this is 8-bit register. So this is your default select. So always RS0 and RS1 will always 0 0, so that it is taken as bank 0. Bank 0 registers are R0 to R7. So this is your register bank select. Next we have the important one is we'll have the parity flag. See, in the parity flag we have number of ones present in the accumulator. Remember, the parity is always checks with the accumulator content. Accumulator content. With the accumulator content, the number of ones or even, then it is even parity. If the number of ones are odd, then it is odd parity. So whenever number of ones are odd parity, then parity flag will be 1. Whenever it is even, parity flag will be 0. So how do you remember this even or odd parity? So remember, parity flag is 1, so 1 is an odd, so that is odd parity. When parity flag is 0, 0 it is even, so that it is even parity. So likewise you can remember the parity flag. So one more time I am repeating this. This will be check the accumulator content. Let's say I'll have an example. So accumulator content, let's say I have 41. So let me see that how we'll check. 40 is 0 1 0 0, okay, 0 0 0 1. So this is the 4 and this is the 1, 41. So number of ones are 2 here, so this is even parity. So even in the sense, so then parity is 0. Okay, let me take one more one. We have the 03H or 1 second, this is also 2H. So this is 0 0 0 0 0 0 1 0. So number of ones are 1, so then it is odd. So odd in the sense, sorry, it is in odd parity, so then P is equal to 1. So I think the parity flag will be clear now. Now we'll come to the one more important one is overflow flag. This is very much interesting concept what we are learning, the overflow flag. The first point is to remember overflow flag will be used when operations done on sign number. Sign number. So how do you see that it is a positive number or negative number? If the MSB bit is 1, it indicates that it is a negative number. If the MSB bit is 0, it indicates that it is a positive number. Example for this, let's say 81. So 81 is 100000001. So this is your MSB bit. This is the 1. So then it is a negative number. Let's say it will take a positive number. Let's say 72. Any number. This is 0, 1, 1, 1, 7 and 0, 0, 1, 0. It is 72. So MSB bit is 0. Then this is the positive number. So with this, we'll find out the overflow. See, for example, I add the sign number. I'll take one example. Add the sign number. Let me add, let's say 81 number as 91. So this is your 91001. So both should be a negative number. I supposed to get the negative. The result I supposed to get the negative number. So this is 00010 to 10001 is carry. So I'm getting the number as this is 1 2h. Carry is 1. So this is a positive number. What I'm getting the result is positive number, but I supposed to get the result as negative number. So this shows a wrong answer. It shows the wrong answer. At that time, the ALU, that is your CPU, identifies it's a wrong answer, then overflow flag will be set. Is it clear? So once you do the sign operation, so anything like multiplication, division or subtraction or addition, anything, in such cases, I'm not talking about all the cases, in such cases, if I did addition, I supposed to get the negative number, but here I'm not getting the negative number because MSB bit is 0. It indicates it is a positive number, but I supposed to get the negative number. I supposed to add both the negative number, I supposed to get negative number. So that it shows the wrong answer. So then it identifies it's a 1. Overflow flag is 1. So one more way it is. So one more way is, so overflow flag is set. Overflow flag is set. There are the two conditions. Another conditions. If there is a carry from D6 to D7, there is a carry from D6 to D7, but no carry out, that is D7 is not generate carry, then that is carry flag is 0. That is, in this case, overflow flag will be 1. Second case, there is a carry out from D7 bit, carry out from D7, that is carry flag is 1, but no carry from D6 to D7 bit. At this instant also overflow flag will be 1. It indicates that if the size is exceeds, then overflow is occur. Size is exceeds in the sense, if this is an 8-bit data, there is a relation, there is a range from negative minus 2 power n to 2 power n minus 1. So if n is 8-bit in the sense, minus 128 to plus, it is a range, plus 127. So this, in this range, if the data bit has stored, if it is exceeds from this, then overflow flag will be 1 for 8-bit operation. Similarly, for 16-bit, we apply into this. Then if you are taken as a 16-bit, the range is, it is between below the 64 kilobytes, that is 2 power 16, it is 64k. It should be in the below this range, otherwise it will be, overflow flag will be 1. So this will be, you can see that if you are do any 16-bit operation in 8051, it is not impossible, because all we done in the 8-bit operation. So that if it is exceeds 64, our memory is only the 64 kilobytes. So if it is exceeds any data, obviously we can come to know that it is overflow flag will be occur. So this is your concept of program status word or PSW. So I think you came to know that the program status word register. Next we'll see the register bank and other register architecture of your 8051. Thank you very much. Hopes you understand very well of the flag contents.